There is a method that costs less than $1 in fuel and takes about 90 seconds per panel. You hold a flame near the faded gray plastic trim on your car. You move it slowly across the surface, and something happens that no trim dressing, no silicone spray, and no $300 dealership restoration service can replicate. The dead oxidized layer melts. The original oils embedded deep inside the plastic migrate back to the surface, and the trim goes from chalky, lifeless gray to factory showroom black in real time right in front of your eyes. 90 seconds, $1, permanent. The color does not wash off in the rain. It does not fade again in 2 weeks. Because you did not coat the plastic. You restored it from the inside out. This is not a trick. This is polymer science. Plastics engineers have understood this thermal restoration process since the 1960s, when polypropylene became the standard material for automotive exterior trim. Every material scientist who has ever worked with injection, molded polypropylene knows that heat reverses surface oxidation by mobilizing the internal plasticizer compounds that UV radiation drives below the surface. It is documented, it is reproducible, and it is the reason your dealership charges $300 to do exactly this with a professional heat gun while telling you the trim needs to be replaced. And someone in a corporate boardroom did the math. The automotive appearance products market generates over $12 billion annually worldwide. Trim restoration products alone represent hundreds of millions. Dealership cosmetic services add billions more. A $1 flame that permanently restores faded trim eliminates the dressing, the spray, the service appointment, and the parts replacement order simultaneously. That is not a competing product. That is an existential threat to an entire product ecosystem. And threats get buried. Welcome to Forbidden Fix. If these stories matter to you, hit subscribe and the bell. This is where we dig up what industries spent decades trying to erase. To understand why a flame restores faded plastic permanently while every spray and dressing fails within weeks, you need to understand what is actually happening to the plastic at the molecular level. The black plastic trim on your vehicle is injection molded polypropylene. During manufacturing, carbon black pigment is mixed throughout the polymer matrix to provide the dark color. Additionally, plasticizers and UV stabilizer compounds are blended into the material to keep it flexible and resistant to sun damage. When the trim leaves the factory, these oils and stabilizers are evenly distributed throughout the plastic, including at the surface. The trim is deep black, slightly glossy and flexible. Then the sun goes to work. Ultraviolet radiation bombards the surface layer of the polypropylene every day. The UV energy breaks polymer chain bonds in a process called photo-degradation. As the chains break, the surface becomes rough and microporous at the molecular level. Simultaneously, the plasticizer oils and UV stabilizer compounds that were originally distributed at the surface are driven inward by the thermal cycling of sun exposure. They migrate deeper into the polymer matrix, away from the damaged zone. The carbon black pigment is still there. It has not gone anywhere. But the smooth, oily surface layer that allowed light to interact with the pigment in a way that appeared deep black is gone. The rough, dried-out surface now scatters light diffusely. The trim appears chalky gray. It is not faded in the way that paint fades. The color molecules are intact. The surface texture has changed. This is precisely why every trim dressing and silicone spray on the market fails. These products coat the surface with a thin film of oil or silicone that temporarily fills the micro-roughness and makes the trim appear dark again. But the coating sits on top of the damaged layer. Rain washes it away. UV exposure breaks it down. Within 1 to 4 weeks, the trim is gray again. And you buy another bottle. The product is designed to create a cycle of dependency, not to solve the problem. Solving the problem requires reaching the plasticizers that have migrated below the surface and bringing them back. No topical coating can do that. Heat does exactly what no spray can. When you apply controlled heat to the surface of oxidized polypropylene, the thermal energy does two things simultaneously. First, it melts the damaged micro-rough surface layer. The broken polymer chains on the outermost surface soften, flow, and resolidify into a smooth, continuous film. The light scattering roughness is physically eliminated. Second, and this is the critical mechanism, the heat mobilizes the plasticizer oils that have migrated below the surface. Thermal energy gives these molecules enough kinetic energy to migrate back toward the surface. As the plastic cools, the plasticizers are once again distributed at the outer layer. The smooth, oily surface is restored. Light interacts with the carbon black pigment through an intact polymer surface. The trim appears deep factory black again, not because a coating was applied on top, because the original material was redistributed from within. This is why the result is permanent. The surface itself has been restructured. Before I go further, this video only covers the basic technique. Inside the Forbidden Fix vault, I have compiled complete plastic restoration guides covering every type of automotive polymer, temperature control charts for different plastic thicknesses, heat gun versus flame comparison data, long-term UV protection protocols to prevent refading, and the exact techniques that professional detailers use to charge $300 to $500 per vehicle. The link is in the description. But stay right here because the economics of trim restoration will change how you see every product in the detailing aisle. Automotive manufacturers have used thermal reformation of polypropylene in production since the material was first adopted. Injection molding itself is a thermal process. Post-production finishing often involves flame treatment to improve surface adhesion for paint and adhesive bonding. The flame treatment process used in automotive factories exposes polypropylene surfaces to a controlled propane or natural gas flame to modify surface energy. The same flame that improves paint adhesion also smooths the polymer surface and mobilizes internal compounds. This is factory standard technology. Heat plus polypropylene equals surface reformation. The physics are so well established that they are taught in undergraduate polymer science courses at every engineering university in the world. Professional auto detailers have known about heat restoration for over a decade. High-end detailing shops routinely use heat guns set between 300 and 500 degrees Fahrenheit to restore faded trim during paint correction details. The service takes minutes. The materials cost pennies. The charge to the customer is $200 to $400. The profit margin approaches 95%. That margin depends entirely on the customer not knowing that the exact same result can be achieved with a $5 portable torch from the hardware store and 30 seconds of controlled application. The automotive appearance product market has a powerful incentive to keep thermal restoration out of consumer knowledge. Trim dressing products generate hundreds of millions in annual retail revenue. Brands like Armor All, Migrate, Chemical Guys, and dozens of others sell silicone and oil-based trim coatings that range from $5 to $20 per bottle and require reapplication every 2 to 4 weeks. A single car owner using these products spends roughly $50 to $100 per year on trim maintenance. Multiply that across millions of vehicle owners, and you have a recurring revenue model worth hundreds of millions annually. A $1 flame that permanently eliminates the need for trim dressing does not just lose a sale, it destroys the entire recurring purchase cycle for the life of the vehicle. And what cannot generate repeat purchases cannot be allowed to become common practice. If you have made it this far, you now understand more about polypropylene chemistry and UV degradation than 99% of people spraying silicone on their bumpers every other weekend and wondering why it never lasts. Subscribe and share. One share is one fewer bottle of temporary trim dressing sold. Here is exactly how to do it. Step 1. Clean the trim thoroughly with soap and water or isopropyl alcohol to remove any existing dressing, dirt, or silicone residue. The surface must be clean and dry. Any residual product can interfere with the thermal process or produce smoke. Step 2. Use a small portable butane torch or a heat gun set to approximately 400 degrees Fahrenheit. If using a torch, hold it 6 to 8 inches from the surface. If using a heat gun, hold it 3 to 4 inches away. Step 3. Move the heat source slowly and steadily across the trim surface. Keep it moving at all times, approximately 1 to 2 inches per second. You will see the gray, chalky surface transform to dark black in real time as the heat reaches the plastic. The transition is immediate and visible. Step 4. Do not hold the heat in one spot. Concentrated heat will warp or bubble the plastic. Smooth, continuous motion is essential. Step 5. Allow the plastic to cool completely before touching. As it cools, the plasticizer set at the surface and the restored appearance becomes permanent. Step 6. For maximum longevity, apply a UV protectant sealant after cooling. This replaces the UV stabilizer barrier and slows future photo-degradation significantly. Total cost per panel, less than $1 in torch fuel. Total time, 60 to 90 seconds per trim piece. Compare that to the $300 detailing service or the $50 per year in trim dressing that washes off every time it rains. I need to be honest with you. This method requires respect and basic caution. An open flame near a vehicle carries inherent risk if used carelessly. Never use a torch near fuel lines, fuel filler caps, rubber hoses, or wiring harnesses. Always mask or protect adjacent painted surfaces with heat-resistant tape because polypropylene trim often sits directly against painted body panels. If you hold the flame too long in one spot, the plastic will warp, bubble, or char. This damage is permanent and cannot be reversed. This technique works on polypropylene and most thermoplastic trim components. It does not work on thermoset plastics or heavily textured rubberized coatings, which have different thermal properties. Practice on an inconspicuous area first. Start with the heat source farther away and move closer gradually until you find the correct distance. And a heat gun is significantly safer and easier to control than an open flame for beginners. The torch produces more dramatic results, but demands more skill and attention. Your father never dealt with faded trim. Vehicles built before the 1990s used either painted metal or rubber bumper components that did not photodegrade the way polypropylene does. When the automotive industry switched to unpainted polypropylene trim in the 1990s, they chose a material that was cheaper to produce, lighter for fuel economy ratings, and easier to manufacture in complex shapes. They also chose a material that was guaranteed to degrade visually within 5 to 7 years. A material that creates a guaranteed aftermarket revenue cycle of dressings, coatings, and eventually replacement parts. There was not a superior material, there was a more profitable one. Subscribe and share. Every share preserves what they tried to erase. The next vault opens soon, and what is inside might explain why your air conditioner has not blown cold in years, while the HVAC company charges $500 for a fix that costs $3.